What you're about to view is a clip from a video game Team Fortress 2. One of the playable characters is Demoman that specializes in grenade launcher and sticky bombs. We are going to compare the virtual physics to the real world physics by comparing the height of an item in the air to other surroundings. It might be difficult to see the height, but I will help you determine it. You will need a stopwatch for this. I will also provide the time for you as well at the end. Start your watch the time grenade leaves the launcher and stops when it hits the ground. Based on 3 successful launches, the time it took for the grenade to leave the launcher and hit the ground was about 1.6 seconds. It took me basically I took 3 tries and averaged them out. Okay, so for this assignment what you will need is the equation. So the equation that will represents the gravity, what comes up must go down, is represented as h of t, which is the height of the time, equals negative 16t squared plus v sub 0 plus let's call this s. Doesn't matter, it's a constant number, so I will tell everything. So this over here, the height, this basically represents the height at any given time. That's why it's h of t. T stands for the time. So height at any given time, and you guessed it right, t would stands for the time. The time it took, the time basically is the time that the object was in the air. The v sub 0 is going to represent the initial velocity. This over here represents initial velocity. What that means is the time it took for the object to be in the air, and it's usually measured in meters per second, but because we're dealing with feet, it's gonna be feet per second. And the last number over here, the s, well, I call it s. Well, this is basically the constant number. In other words, the height of the person who's kicking the ball or throwing something to the air. So this will be the starting height. What I forgot to mention in the last clip is to include this t over here. It has to be there, okay? Because our initial velocity is measured in feet per second, so the time has to be here. Now, okay, so now what we will do is we'll try to find out what was our initial velocity. So we're trying to find out this thing right here, our v sub 0. And how can we do that? Well, we knew that it took about 1.6 seconds for the ball to hit the ground, and when it hits the ground it was at the height 0, our ending. So we can replace also this thing right here, the h of t, with 0. So our equation will be 0 equals to negative 16 t squared. Well, we know that our time is 1.6, then we're gonna go 1.6 squared, plus we need to find out what our v sub 0 is, so we'll leave it as v sub 0 times, let's call this 1.6, plus, and the c over here represents the initial height, and the grenade was about 3 feet from the ground, so we can put 3. Now what we have to do is combine the like terms. So we'll leave the 0 here, so we have negative 16 times, well, 1.6 squared is 2.56 plus v, well, what we can do actually is we can place the 1.6 first and then the v sub 0 last, plus the 3, and let's find out what this is. So negative 16 times 2.56 comes up to negative 40.96 plus 1.6 v sub 0 plus the 3, and then we can combine this term and this term. So what we'll come up to is negative 40 plus the 3, which comes up to negative 37.96 plus 1.6 b sub 0. The next thing that we need to do is we need to move this term onto the other side, and how? By doing the opposite. So plus 37.6, and on this side too. So we'll come up with 37.96 equals to 1.6 b sub 0, and then we need to get rid of the coefficient, so we simply divide by 1.6. And now positive 37 divided by 1.6 comes up to about 23.75. So our initial velocity was 23.725, so we can round it off to about 23.7. Let's go with the 3. So that's how fast it was. Basically, the initial velocity was 23.73 feet per seconds. Now that we found out what is our initial velocity, we can put together the equation that we will work with. And this is our equation: h of t equals negative 16t squared plus 23.73 t plus the 3. And this like I said before, this looks similar to our standard form. And actually, this is our standard form. So we know what our a is, we know what our b is, and we know what our c is as well. So at this moment, what you have to do is you need to find the vertex, and the equation for it is x equals to negative b over 2a. The only difference is, instead of x, we are using the t because our x-axis represents the time. So we simply will have t equals to negative b over 2a. What this time represents, it represents the time at which your object was at the highest point. So for example, this is our equation like that. This point over here, which is our vertex, the highest point, and because our x-axis is the t and our y-axis is the height, at this specific time it will show us what was our height. So once you do your calculation, you will find out what t is, and in order to find out the height, the highest point of that object, is to substitute it back into your original equation. So what you will have is h of t equals to negative 16, input your whatever time came to be, or whatever your t, squared, plus 23.73 times whatever t is equal to, plus 3. So what you will be able to find, you will be able to find the highest point, in other words, the maximum height that your grenade was in the air. That's the maximum, and that's how you find this stuff.